Bun was ported from SIG to Rust. You probably already heard about that, but there's a lot to unpack here. There has been a lot of drama last week, but there's a lot of interesting stuff going on. And no matter if you're interested in Bun, SIG, or Rust, this is really interesting, also regarding how AI was leveraged and what that could mean for similar projects in our industry in general. Now, just as a little side note, I personally like Bun quite a bit. It is my default JavaScript runtime I use in most of my projects. And indeed, as a nice coincidence, I published a brand new course on Bun last week, and it works, of course, for the Rust version as it does for the SIG version. So if you want to dive a bit deeper into Bun and learn about all the core APIs it has to offer, because that's one of the biggest advantages of Bun, that it has so much stuff built in. Some people don't like it. I love it. If you want to learn more about that, that course may be interesting. But let's now take a closer look at the overall porting timeline, shall we? It actually happened 2 months ago. So the blog post was released last week in July, but the port itself happened in May. And it started in early May when the Claude Phaser port branch was discovered on the official Bun GitHub repository. That branch contained a porting MD file, a markdown file, with instructions on how to convert SIG code to Rust code, how to port that code. Translation tables, and in general instructions. And we'll get back to how that file was created, because of course AI was involved, as you may guess, a little bit later. That was discovered, so naturally discussions ensued on Hacker News on X, and there were people excited about that. There were people very critical of that. But at that point, we didn't know a lot. Obviously, there is a lot of polarization around Rust. There are people that love Rust, like myself. There are people that hate Rust. There are people that hate that everything should be rewritten in Rust, because very often you read that people want program XYZ to be rewritten in Rust, and I get that this is annoying. But naturally, therefore, there was a lot of polarization there going on, but the port had not yet happened. That changed later in May, and on May 14th, an official pull request was opened and then also merged that actually migrated the Bun codebase, all of it, from SIG to Rust. Now, as you can see, it's a huge pull request. More than 1 million lines of code were added, and the removal of the SIG code happened in a different stage. So yeah, that's why it's not a swap. But it's a huge change, as you can see, with almost 7,000 commits. Now, naturally, that code was not human reviewed, at least not entirely. It was reviewed by AI. It had passing tests, but it was not human reviewed, and we'll get back to how AI was used in just a second. But that was published or merged, and of course more discussion ensued now. As I just mentioned, it was not reviewed by humans. That's impossible to do in that time frame, of course, but the community dove in and had a look and analyzed parts. And then there was another, or a first blog post, not the official one about all the details, but one first blog post or statement released by the Bun team about the use of unsafe. Because one big criticism that came up after this pull request is that the Rust code in there was not idiomatic Rust. It was not the kind of Rust code you would or should write if you were building this from scratch. Instead, it really was like a translation from SIG to Rust. And that meant that not all those Rust best practices and patterns were used, and especially there was a decent amount of unsafe usage in there. Now, to understand unsafe, you have to understand how Rust manages memory, because that is one of its biggest advantages, and it's quite different from other languages. Because in most languages, you have either a garbage collector, which is a process that basically detects when a value is no longer used anywhere in the program and then frees up the memory, which is convenient but consumes extra resources. Or you have to do it yourself. In languages like C, for example, you have to manually allocate and free up memory, and it's the same in SIG. You can allocate memory there, but you also have to call free, or you have to free it up when you no longer need it. You can use defer, which is nice. That basically means you can call that before it's actually executed. It is deferred and will be called automatically when this scope ends essentially. And that's nice because there are different situations where a value may no longer be needed. But still, when you have to clean up memory manually, there are many situations where you can shoot yourself in the foot. You have more fine-grained control, and that can be very useful, very efficient, but it's also easy to forget situations in more complex programs where you then may not be cleaning up memory, hence introducing a memory leak, or where you may be cleaning up twice, which will also cause an error, and therefore there is a trade-off. And Rust has a different approach. In Rust, you have a concept called ownership, which means that every value has exactly one owner. And it's tied to scope. So if you have a scope, and you can create scope by using curly braces, or a function would also have its own scope. You may know that concept from JavaScript. If you have scope, then when a value is created in there, it's owned by that scope. And if the scope ends, it's freed up. And that, of course, is very convenient because you don't have to take care about freeing it up. You also don't have a garbage collector. Instead, you have that clear rule. That can lead to complexity in more complex programs where you need to pass values around. You can do that in Rust, but it requires a different way of thinking. But of course, it gives you memory safety, unless you use the unsafe keyword. If you use that, you can create an unsafe scope. And in there, those rules no longer apply, and it's then your job to make sure that memory is managed appropriately. Now, why would you do that? Well, for example, if you're pulling in some C library, which you can do in Rust, you can blend in some C code, so to say, or call some C library methods and functions. Then, since C is naturally unsafe, the code where you reach out to that C code is also unsafe. So you need that feature to interact with other unsafe code. And that is also one thing they noted in that official statement, that all those unsafe usages in the codebase, to a decent part, were actually related to calls to other libraries, C libraries, and so on, which won't change. But they also identified areas where they could actually improve the code and get rid of unsafe. And they mentioned that they would do this in subsequent pull requests. And they did and still are doing that. So you can think of this initial port as like a starting point, which then got refined over time. Still worth mentioning that this initial pull request, or that huge pull request, already had passing tests. So it was stable, the tests were passing, but the code was not of the code quality you would maybe expect if it were written in Rust from the ground up, because that wasn't the goal. So that was May 21st. Then there was silence, and it's also worth noting that this version of Bun was not released yet. And when I'm recording this, it's still not live. When you're installing Bun right now, you're still getting the SIG version, but that should change any day now. But then on July 8th, the official blog post was released, where we find lots of interesting details about this port. And it's really worth reading. I'll link it below, because there is a lot to learn here. This entire port, and that's no secret, was done with help of AI. It's worth keeping in mind that Bun is owned by Anthropic, so they had free access to all those tokens, and especially also to Fable 5 before it was released to the public. This port was done with Fable 5. And if you're installing Claude Code now, by the way, even though Bun 1.4, the Rust version, is not released yet, Claude Code is already running on top of an unreleased Bun version, so to say, that is the Rust version. So there's that. But yeah, this port was done with Claude Code based on Fable 5 with free tokens, of course, essentially, since Bun is part of Anthropic. And that's important to keep in mind, because in that blog post, we learn that if you were to combine all the tokens, or if you were to sum up all the tokens that were spent and charge API prices, this entire port would have cost around $160,000. That's a mind-blowing number, but actually, if you think about the scope of this project, and the scope is that Bun was 535,000 lines of SIG code, if you think about that scope and how long it would take humans to port that to Rust, then the $160,000 actually might not sound too bad, depending on where you're located. Now, nonetheless, it's clear that no open source project would be able to do that, and most companies would probably not be able or willing to spend that amount of money on a port. This is possible because Bun is part of Anthropic. And of course, this is also a nice marketing stunt for Anthropic. That may not have been the main intent. I don't know that. But of course, it's nice marketing. That is all important to keep in mind. Nonetheless, in this blog post, we can learn how Jared did that port, or how he made that port work. And that all started with that porting MD file, which he created in a discussion with Claude, in a 3-hour discussion, as he mentioned in that blog post, where he essentially decided together with Claude code and the Anthropic models how such a porting MD file would have to look like to be able to translate SIG to Rust code. Then, once he iterated on that and was happy with it, he tested it on 3 files initially, and once he was happy with that, he unleashed Claude on the entire Bun codebase. Now, in this blog post, he makes it clear that he did not just prompt Claude to rewrite Bun in Rust, make no mistakes, but that instead he set up an elaborate system where he had one main agent, spinning up sub-agents too, of course, doing the port according to the porting MD file. And then he had 2 adversarial review agents that reviewed the work of that main agent once it was done and provided feedback, and then a fixer agent for applying that feedback. And he had that all running in a loop and of course distributed across multiple work trees to process the entire code base and work its way through it. In the blog post, he mentioned that he rewrote Bun in Rust using 50 dynamic workflows in Claude Code, which are these workflows that spin up a lot of sub-agents over the course of 11 days. And he also has a nice chart in there. In general, in the blog post, there are nice graphics in there that make it a bit easier to digest, that show the amount of commits that were created and then pushed on the different days and times of the day. So that all happened with help of loops in Claude Code, with help of a lot of sub-agents and that clear process of one main agent, the review agents, and the fixer agent. And then he also did another separate pass, so to say, making all those tests work. And that brought its own challenges because the test suite is so large and complex that he ran into various infrastructure restrictions, because some tests consume a lot of memory and running many tests in parallel therefore doesn't work. But ultimately, he made that all work, also with help of AI, running the tests, fixing the code, rerunning the tests, and so on. So lots of looping, lots of agents and sub-agents involved naturally, and lots of tokens burned. $165,000 in tokens burned. Now again, you can dive in deeper, and that is what I would recommend doing if you're interested in all the nitty-gritty details. It's a really great blog post documenting the journey to getting there. But that is in a nutshell how the port happened over 11 days with all those agents and sub-agents distributed across multiple workflows, 50 such workflows as we learned, across or over 11 days, $165,000 spent in tokens at API prices. Now, finally, once he was done, in the blog post, he mentioned that Bun 1.4 fixes various bugs that the last SIG version has, that it's more memory efficient, that it's smaller. And as we learn by the response of Andrew Kelly, the creator of SIG, some of these improvements could have probably also achieved with SIG. But that blog post is pretty interesting because it got edited. It's less full of anger now than it was initially. The first version was full of personal attacks, just to then say that it was not meant as a personal attack, but it was full of personal attacks. The latest version, which I'll also link below, is still pretty spicy. In the end, you can clearly tell from reading the first version, but also this version, that Andrew, the creator of SIG, and Jared, the creator of Bun, they won't become best friends anymore, or again. Now, he thanks Bun for supporting SIG, also financially, just to basically, rage about this entire port and how it wouldn't have been necessary if the Bun code would have been written in proper SIG. He makes it very clear that he doesn't feel like the Bun repository, the SIG version, had a high code quality, and that led to many problems. And that may or may not be true. I think it's absolutely possible that in a project of the scale of Bun, moving at the speed in which Bun moves, code quality may not have been up to the standards of the creator of SIG. You could definitely argue that most code projects don't necessarily have the highest code quality though, so you can make of that whatever you want. Now, I'll leave it at that. I feel like the overall response blog post is pretty weak because it is so steaming with anger. It has some valid points, like, for example, in the blog post Jared makes, he mentions that the port from SIG to Rust was validated, of course, with all these reviewer agents, but also by running the test suite and making that work. And Andrew correctly states that, of course, that same test suite should or should not have been sufficient to prove that the SIG version is great, so maybe the test suite should have been improved too. Either way, definitely these two won't become best friends, and I have no opinion on whether SIG or Rust is the better language in general or for Bun. I do believe, however, that with AI, Rust and its memory model, and the fact that you get compile time errors for many memory-related issues, is a huge advantage, especially in the age of AI. Because, of course, this entire port is really impressive when it comes to the use of AI. And sure, it's a way of using AI that most of us won't be able to afford or won't be willing to afford in companies. But it's impressive that AI was able to do that. And it's not vibe coding or just YOLO prompting. There is a clear process behind all of that. A lot of thought went into this, which I hopefully made clear, which definitely also gets clear if you dive into the nitty-gritty technical details. But with all the planning, all the iteration, with the setup, with the way this was approached, clearly this was not just one prompt thrown at it and then we'll see where we get. This shows what you can do with AI. And of course, porting a code base from one language to another is a pretty good use case for AI. If you think about it, AI can, of course, struggle with writing new code. It may not write the code you wanted to write, not follow the code conventions or styles you wanted to follow, and it may also mess up things. Now, definitely, AI is amazing for building new software too, but you face a different set of problems there. With a port, the huge advantage is that you have a code base for the AI to just look at and translate, which is something AI can do, and you have a test suite there. So there's a lot to build up on. It's a good use case for AI, as it seems, and as this port clearly proves. And I think that is the most interesting takeaway here. Also, that you can tackle projects that just would have been impossible to tackle before. Again, not for everybody, but for certain companies of certain sizes, this may be interesting. Modernizing legacy software with help of AI can or may be a great use case. And this shows and proves that this can be done. Now, of course, Bun 1.4 is not out yet. We'll see if everything crashes and they have to revert in a month from now. You can't totally rule it out, but I personally don't think that will happen. It is being used in production by some early adopters already, like the Claude Code CLI. It has been tested and reviewed extensively, even though, of course, by AI, not human reviewers. But I'm pretty confident that this will work out, and I find it a pretty impressive feat and also a pretty impressive usage of AI. But as always, I'm also interested in hearing what your thoughts are about all of that.